Okay, guys, welcome. Today we're going to talk about complex numbers. Okay, so the reason why we need to talk about complex numbers is for equations that look something like this, right? Now, we said before that if you have a number being squared, it can never be negative because if you're taking a number and multiplying it by itself, you're either doing positive times positive or you're doing negative times negative, right? In either case, you're going to end up with a positive number. So something like this, if you just sort of take the regular rules in numbers, is not possible, right? Now, to sort of get around this problem, mathematicians created a new number system, right, to get around this problem, right? And it's sort of built around the idea that if we allow a square root to have a negative inside of it, then we can get an entire new branch of different results, right? And it's all going to basically revolve around this imaginary unit I, which is the square root of -1, right? And of course, if you square it, you get -1, which under normal operations would sort of be ridiculous. But if we allow this to be true, then we can sort of get around that. Okay. Now, first of all, I just want to talk about some powers of I, right? So before we do these examples, let's look at something. So we said that I is square root of -1. I squared is obviously just -1 then. Well, then I to the third is like I squared times I, which is like -1 times I, which is -I. So far we have I, we're just going to refer to as I squared is -1, and I to the third is -I. Well, I to the fourth, we could say is I squared times I squared, which is -1 times -1, which is +1. So I to the fourth is +1. Well, now what happens if you do I to the fifth? Well, this is I to the fourth times I, and that's just 1 times I, which is I. So I to the fifth is also I. And you can imagine that this is just going to keep repeating, right? Right? And this will keep going around and cycling and repeating again. All right? So essentially what we can now do is we can say that if we have I to the any power we can think of, we basically have 4 possibilities. Right? If m is just 4, a multiple of 4, like 4 times, let's not use m, let's say 4n. Right? So this is a multiple of 4. Right? Well, then you're just going to get 1. If it's a multiple of 4 plus 1 more, then that's when you get I. If it's a multiple of 4 plus 2 more, that's when you get -1. And if you get a multiple of 4 plus 3, that's -I. Right? So now even we can look at these much tougher powers, right? So if we look at I to the 101, for example, right? If you divide 101 by 4, well, how many times does 4 go into 101? Well, you're going to get 25 with 1 left over. So we could say that this is I to the 25 times 4 plus 1. So this is a multiple of 4 plus 1 more. So this is I. Okay, for part B, we have the negative, but that's just going to sort of come through with it. We have I to the 74. Now, if we divide 74 by 4, let's see, we could go in, I believe that's going to be, so 4 times 20 would be an 80. So if we go 19, that would be 76. And if we go 18, that would be 72. So we're going to get 18 plus 2 more, right? So this is 18, I should say this is I to the 18 times 4 plus 2, right? So since it's a multiple of 4 plus 2, this is going to be negative 1. But now don't forget the negative from before, so this will make this a positive 1. Okay? Part C, we have I to the 36. And of course, if you take 36 and you divide it by 4, you get 9 right away, right? So this is equal to I to the 9 times 4. So it's a multiple of 4, so it's just 1. Okay, and then finally, part D, we have I to the 51, which if we take 51 and divide by 4, we'll get a 12 with 3 left over. Right, so we could say that 51 is 12 times 4 plus 3. Right, so this is a multiple of 4 plus 3, so this is negative I. All right, now this is just sort of like an interesting little fact. If this, if you don't really like this, it's not too critically important, but it's sort of an interesting fact. Okay, now let's talk about when we look at, for example, if we have something like a squared equals negative 25, which then means that a is the square root of negative 25. All right. Now, before we would say that this is not possible or that it has no solution or something like that. All right. But what we're going to now do is we're going to say that if we have something like negative square root of 25, or square root of negative 25, I should say, we could think of this as the square root of 25 times negative 1, which is the square root of 25 times the square root of negative 1. And we know that the square root of negative 1 is just I. So we could say, for example, this is 5, since that's the square root of 25, times I. Right? And that's generally the idea here. If you have a negative inside of a square root, you want to take an I out front, and then you can make that square root positive again. Right? Now, of course, if you have any number times I, right, this is called an imaginary number. All right. So far, everything that we've looked at before has been a real number. This is now venturing outside of the real numbers, and this is where you now have imaginary numbers. Okay. Now, of course, if you combine a real number plus an imaginary number, we call that a complex number. All right. And of course, the number A is called the real part of a plus bi, and then the number b is called the imaginary part, since that's sitting in front of the I. All right. And then one thing that you could also say is that every real number is also a complex number as long as you just set b equal to 0. Okay. So let's write each of these as a complex number. So part A, we have negative 1/2. All right. Well, this is already a real number, so it's a complex number. Right? If you really wanted to, you could say this is negative 1/2 plus 0 times I, but we usually don't do that, right? So this is actually fine as is. Now, part B, we have square root of negative 9. Since I have a square root of a negative, I want to pull an I out and then make that positive. Well, what's the square root of 9? It's 3. So this is 3 times I. Okay? Part C, we have a negative 1 minus square root of negative 4. So for the square root, I'm going to pull out an I again and make that positive square root of 4. So now we have a negative 1 minus 2I, since the square root of 4 is 2. Part D, we have 0.2, and that's already a real number, so it's a complex number again. Okay, so that's good as it is. For part E, we have negative square root of negative 3. So let's pull out our I again. And we can even just leave this as is. We can write this as negative I times square root of 3 or negative square root of 3 times I. Both of these are saying the same thing, and both notations are really used pretty interchangeably. This one might be preferred because it's definitely clear that the I is on the outside, whereas in this one, it might be ambiguous if the I, for example, if your square root looks more like that, is the I under the square root or not? But most of the time, it's written in a way that you can easily tell. So either one of those is fine. Okay, now in part F, we have 3 minus square root of negative 9. Okay, so we can write this as a 3 minus I squared of positive 9. So we're going to get a 3 minus 3I. And that's our final answer there. Okay. So now that we've talked a little bit about writing complex numbers, we can now start to talk about operations with complex numbers. Okay. Now, we say that two complex numbers are equal if their real parts are equal and their imaginary parts are also equal, right? So if you have the same thing, then they're equal, right? So hopefully that's pretty obvious. Now, in order to add and subtract complex numbers, you're essentially just adding the real parts together and adding the imaginary parts together and then putting that in front of I, right? You're essentially combining like terms is really what this is saying. And then of course for subtraction, you're distributing the negative and then combining like terms, right? So let's do a couple examples of that. So in part A, we have a 7 minus 2I plus a 4 minus 3I. So we add our real parts. So if we add 7 and 4, we get 11. If we add our imaginary parts, we get negative 2 minus 3 is a minus 5, and then we multiply it by I. Okay, part B, we have 3I plus negative 7 plus 5I. So for our real part, it looks like we just have a minus 7, and for our imaginary part, we have an 8I. For part C, we have negative 11 plus 5I. Minus 9 plus I. So once we distribute our negative, this is going to become minus 9 minus I. So you get a minus 20 plus 4I. Okay, and then finally part D, we have a 14 minus 3 minus 8I. So once we distribute our negative, we have a 14 minus 3 plus 8I. So we get an 11 plus 8I. Okay, so that's adding and subtracting complex numbers. So that's pretty straightforward. Now, when we multiply complex numbers, we essentially are going to multiply not only two polynomials together, but you're essentially going to be doing FOIL, right? And then what's going to happen is that you're going to end up with AC plus ADI plus BCI, and then you're going to get a plus BDI squared, right? Now these two things, these two I terms are just going to get combined together. But what's I squared? I squared is negative 1. So this is going to become minus BD. So then that's where you're seeing this AC minus BD pop out here. All right, so let's do a couple of examples. So in part A, we have a 2 minus 3I times a 7 plus 5I. So if we FOIL, we're going to get a 14 plus 10I minus 21I minus 15I squared. All right, so now if we combine, we're going to get a 14 minus 11I. And then again, remember what I squared is, it's negative 1. So we're going to get minus 15 times negative 1. Well, that's going to make this a plus 15. So we're going to get 29 minus 11I. Okay, and then for part B, we have a negative 3 minus I times a 4 minus 2I. So we get a negative 12 plus 6I minus 4I plus 2I squared. So now if we combine, we get a negative 12 plus 2I, and the I squared will make this a minus 2. So we're going to get a minus 14 plus 2I. And then finally in part C, we get a minus 4 minus 2I times a 2 minus 3I. So when we FOIL, we're going to get a minus 8 plus 12i minus 4i plus a 6i squared. So once I make this 6i squared a minus 6, I'm going to get minus 14 plus 8i. Okay, and then that's part C. So that's multiplying with complex numbers. So that's fairly straightforward. Okay. Now, just like when we had conjugates when we wanted to rationalize a denominator with more than one radical term, and we called that the conjugate, a similar thing works in complex numbers when we have the complex conjugate. So the complex conjugate of a complex number is the same thing except you're changing the sign. Right? And why that might be useful is because if you multiply a complex number and its conjugate, you end up with strictly a real number, right? Because your I terms will cancel out, right? So let's go ahead and we'll look at that sort of in motion here. Let's go ahead and we'll multiply each of these complex numbers by their conjugate, right? So the conjugate is just to change the sign, right, in front of the imaginary number. So this will become a 36, and then we'll get plus 6i, which we'll show it out one time, and then minus 6i, and then we're going to get a minus I squared. Well, the 6i's cancel, and this will become a 36 minus negative 1 because that's I squared, so we're going to get a 37. Okay, in part B, we have a negative 3i, and the conjugate of negative 3i is a positive 3i, right? We change the sign of the complex number. Here there's no, of the imaginary part, I should say, and here there is no real part. So here we're going to get a negative 9i squared, and the I squared will just make this a positive 9. Now in part C, 4 is already a real number, right? So the conjugate of 4, right, you can think of 4 as 4 plus 0i. The conjugate of 4 plus 0i, you could maybe say is 4 minus 0i. But really, what is this is just 4 times 4. So this is 16. Okay, part D, we have 3 plus 2i. So its conjugate is 3 minus 2i. So we're going to get a 9. Middle terms will cancel. And then we're going to get a minus 4i squared. So we're going to get a 9 plus 4, so 13. Okay, and then finally, part E, we have a negative square root of 2 minus 3i. So then if we multiply by the conjugate, so negative square root of 2 times negative square root of 2 will give me a positive 2. And then the middle terms will cancel, and then minus 3i times plus 3i is minus 9i squared. So that's going to give us a 2 plus 9, which will give us an 11. Okay, now this brings us to the next thing, right? When you have division of complex numbers, right, we don't want any radicals in any denominator, and I is a radical, right? It's square root of negative 1. So we're going to use the complex conjugate whenever we divide by complex numbers, right? That way we'll get something where we don't have radicals in the denominator. So let's do a couple of examples of that. So in part A, we have negative 2 plus 3i over 3 minus I. All right, so we're going to multiply the top and the bottom by the conjugate. And if we do that, the bottom is going to become, it's a difference of 2 squares, so it's a 9 minus I squared. And then in the top, we FOIL. We get a minus 6 minus 2i plus 9i plus 3i squared. So now if we change our I squareds to negative 1s, this is going to become in the top, we'll get a negative 9 from minus 6 minus 3 plus 7i. And then in the bottom, we're going to get a 10. And of course, you can either write this as negative 9 over 10 plus 7 over 10i, or you could write it, you could even just keep it just like this, right? I usually prefer this form because then you can clearly see the imaginary and the real components right away. But the one above it is certainly not wrong. Now in part B, we have a 2i over 2 plus 5i. So in this case, my conjugate is 2 minus 5i. And we get a 4. And then once we cancel our middle terms, and we have 5 times negative 5 is a negative 25, and then we'll have I squared, so it'll become a plus 25. And then in the top, we'll have a 4i minus 10i squared. So we're going to get a positive 10 plus 4i, and each of these will be over 29. Okay. Part C, we have a 1 minus I over 2i. Now, technically, the conjugate is a minus 2i. So let's multiply by that. If you multiply the top and the bottom by I in this case, that would work just as well, because then you get a 2i squared. But we'll multiply using a conjugate. And then here in the bottom, we're going to get a minus 4i squared. And then in the top, we'll get a negative 2i plus a 2i squared. So we get a negative 2 minus 2i over a positive 4. So we get a minus 1/2 minus 1/2 I once we simplify. Okay. And then finally, part D, we have a 4 minus 2i over 5 plus 2i. So if we multiply by the conjugate, we're multiplying by a 5 minus 2i. So in the bottom, we're going to get a 25 plus 4 once all is said and done, right? Because 2i times 2i, with it being negative, will be a minus 4i squared and a plus 4. So then we'll get a 20 in the top, and then minus 8i minus 10i plus a 4i squared. So we're going to get a 16 minus an 18i, and each of them will be over 29. Okay, so that's doing some division with complex numbers. Okay, so the last thing that we'll talk about in this video is the idea of finding the reciprocal of a complex number, right? So now to find the reciprocal of a complex number, if you have s plus ti, the reciprocal means that you want to flip it. So you want 1 over s plus ti. But then you need to multiply by the conjugate so you don't have any radicals. And then what will happen is you get s minus ti over s squared plus t squared once everything is all settled here. All right, so let's do a couple of examples of that. So in part A, we want the reciprocal, right? So we want 1 minus 2 over 2i. So if we multiply by the conjugate, multiplying the top and the bottom by 2 plus 2i. So here I'm going to get a 4 minus a 4i squared, so plus 4. So we're going to get a 2 plus 2i over 8, which we can simplify to be 1/4 plus 1/4 I. Okay, part B, we have 3i. So the reciprocal would be 1 over 3i. And if we multiply by the conjugate, we can multiply by negative 3i. So we get a minus 3i over a minus 9i squared, or a plus 9. So we get a minus 1/3 I. Here, this is purely imaginary. Okay. Part C, we have 3 minus I. So the reciprocal is 1 over 3 minus I. So when we multiply by the conjugate, we get a 3 plus I over a 9 plus 1, right? Because minus I times I will be a minus I squared, and then it'll become plus 1. So then this is going to be a 3 over 10 plus 1 over 10i, once we separate that there. Okay, part D, we have a 1 plus 3i. So our reciprocal that we want is 1 over 3, 1 plus 3i. So then multiplying by the conjugate, we get a 1 minus 3i. So we're going to get a 1 minus 3i over a 1 plus 9, right? So we get a 1 over 10 minus 3 over 10i. Okay, and then last but not least, we have a minus 2i. So the reciprocal we want is 1 over minus 2i. So the conjugate is 2i, positive 2i. So we get a 2i over negative 4i squared. So we get a 2i over 4. So we get a 1/2 I. Okay, so I believe, yep, that's the last example. Okay, so that concludes this video on complex numbers. I hope you enjoyed, and I will see you next time.